Alright, so y'all go ahead and do the factoring and the math knowledge question today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you want to do remove, replace, reduce. So if we remove the 4, we'll have x squared minus 60x plus 900. And then when you replace and factor, you'll have 4x minus 30 times 4x minus 30, both of which we'll divide by 2. So we'll be left with 2x minus 15 times 2x minus 15, which you can also write as 2x minus 15 squared. For the math knowledge question, we have a right triangle, and we want to figure out how long the hypotenuse is. So we're going to use trig, and we're going to want to use the cosine of 53 is equal to 2 over the hypotenuse. So if I multiply by the hypotenuse, I have h times cosine of 53 equals 2, and then I'll divide by the cosine of 53. And so if you plug that into your calculator, you should get 3.3, and that would be C for your answer. Okay? So we are looking at lesson 46 today. We're going to look at complex roots and factoring over the complex numbers. But before we do that, we are going to have our 4th trig quiz. So y'all go ahead and get those out, flip them over face down on your desk. Once y'all are ready, unpause the video and I'll get the timer going. Alright, so on your mark, get set, go. All right, so y'all go ahead and stop. Put your pencils down, go put it in the basket. Y'all pause the video, and then once you're ready, we're going to go on to lesson 46. So we're going to be looking at complex roots and factoring over the complex numbers. So hopefully you'll understand complex roots and you'll understand how to factor over the complex numbers. So for quadratic equations that have real number coefficients, your complex roots are always going to occur in conjugate pairs. So remember, conjugates are like 1 plus 3i and 1 minus 3i, where the sign in the middle is changed. So if you have a complex root and one of them is 1 plus 3i, the other one is going to have to be 1 minus 3i, because they always happen in conjugate pairs. So we have the quadratic equation where we have a lead coefficient of 1, and the roots are 1 plus 2i and 1 minus 2i. So we're going to start off by saying x minus 1 plus 2i times x minus 1 minus 2i equals 0. And then we're going to distribute this little negative here. So that's going to be x minus 1 minus 2i times x minus 1 plus 2i. And then we're going to distribute. So we'll have x squared minus x plus 2xi. And then minus x plus 1 minus 2i minus 2xi plus 2i, and then minus 4i squared. This I squared becomes a plus 4i. Plus 4. The I squared cancels and changes the signs. So now, if we look, we have a plus 2xi and a minus 2xi that cancel, and we have a negative 2i and a positive 2i that cancel. And so you're left with x squared minus 2x and then plus 5 equals 0. So that would be your answer. So whenever you're making your quadratic equation, when you get to your final answer, all of your i's should cancel out. If they don't, you did something wrong when you distributed. Because we want to end up with something that looks like what we try and factor. Obviously, x squared minus 2x plus 5 doesn't factor, but if you use the quadratic equation, the quadratic formula to solve this equation, you would get x equals 1 plus or minus 2i, because that's what they told you your roots were. So if you want to check it, just use your quadratic formula, and that would give you what they started with. Okay, so now we're going to factor over the set of complex numbers. So we're basically going to be going backwards. And it says factor over the set of complex numbers. That means that when we go to factor this, we are going to have to use the quadratic equation. All right, so we're going to factor out a 2 first. And so if we factor out a 2, we have x squared plus 2x plus 4, which doesn't factor like we normally would factor. Nothing multiplies to give us 4 that adds to give us 2. So we have to use our quadratic formula. So negative b plus or minus b squared, which is 4, minus 4 times a times c, all over 2a. So we get negative 2 plus or minus 4 minus 16 all over 2. So negative 2 plus or minus the square root of negative 12, which would be 12i, all over 2. The square root of 12 will reduce to 2 square roots of 3. And then we can divide all 3 of these by 2, leaving us with negative 1 plus or minus the square root of 3i. But we want to factor it, so we need to have it as x minus a number times x minus another number. So x minus, I'm forgetting something in front. We have a 2 out here, so we need to have 2 and then. x minus negative 1 plus the square root of 3i, and then x minus negative 1 minus the square root of 3i. So you have to make sure you distribute your negative completely here. So you should end up with 2 times x plus 1 minus square root of 3i, and then x plus 1 plus the square root of 3i. And so that would be your answer. That's how you would factor it. Okay, so we're going to look at another one. We want to factor x squared plus 2x minus 5. And it doesn't tell us over the complex numbers, so maybe this factors as normal. But if you check, nothing multiplies to give you 5 and adds to give you 2. So we're going to have to use the quadratic formula to find our x values. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 2 plus or minus 4 plus 20 over 2, negative 2 plus or minus the square root of 24 over 2. So negative 2 plus or minus, this will simplify to 2 square roots of 6. And then all of those will divide by 2 to give us negative 1 plus or minus the square root of 6. So when we factor it, again, we're going to have x minus a number times x minus the other root. So x minus negative 1 plus the square root of 6. And then x minus negative 1 minus the square root of 6. And then we distribute our negative, and we get x plus 1 minus square root of 6 times x plus 1 plus the square root of 6. And so that would be how it factors. Okay, so that's how you factor using your complex numbers. Your homework tonight, you have 1 through 30. There aren't any to omit. So make sure that you do those tonight so we can go over any questions you have tomorrow.